In Theorem 12.1, we're going to talk about rules of multiplication. And these are things that we just take for granted in all the different sets that we usually work with. So when we work with real numbers, or if we work with integers or rational numbers or even matrices, we just use these rules without thinking. But in Theorem 12.1, we're actually going to show that they are true for rings in general, and we're going to prove a few of them. So we take a few elements in our ring, A, B, and C. Then if you're taking a ring element A and you multiply by 0, which is our additive identity, either from the right or from the left, you get 0. So, we know that's true in the integers. 5 times 0 is 0. But that's actually true in every ring. If you are taking, for number 2, A times minus B is equal to minus A times B, which is equal to minus A times B. And here we can decode that a little bit. What is minus B? It is the additive inverse of B. And so if you're taking A and multiplying it by the additive inverse of B, that is the same as taking the additive inverse of A and multiplying it by B, which is the same as taking the inverse of A times B. Now, there's really no reason why that should be true in general when you are talking about it like that, so we're going to prove that that's true. Number 3, the additive inverse of A times the additive inverse of B is the same as A times B. Also, why is that true? It is. 4, if you have A times B minus C, that is equal to A times B minus A times C. And also B minus C times A is B times A minus C times A. So this is like the distributive property for subtraction instead of addition. But again, what is subtraction really? B minus C is B plus the inverse of C. And then if R has a unity element, then the inverse of that unity element times A is the inverse of A. And for 6, we have the inverse of unity times the inverse of unity is unity. Okay. We are only going to prove a few of those in the next few videos. So we are going to prove number 1 and we're going to prove number